Did he record this morning? No, right now, in the land of me, it's actually Wednesday. But believe it or not, through the art of technology, you can see something that happened a day before and still learn from it. I think that's pretty super special awesome. So here is our learning goal for today. You should write that down in your learning log. You're going to need to take some notes in there as well so that we can make sure that you've learned something from today, and then you can meet these goals. So pause your video at any point if you need to take a little bit of time to look. I know the video should be about 15 minutes long, but I don't expect it to take just 15 minutes. I expect you to pause your video quick frequently so that you can wrestle with the topics at hand. So hopefully you have that written down in your notes section. Our agenda for this video is we're going to do an opening to get thinking about these types of problems and what sort of problems you might face, and see if you can solve them even without knowing any rules. Then there's a little bit of bookwork. Then we're going to do a little bit of a closure in the video to make sure you've learned what you've needed to. And then I'll go through some practice problems and give you a chance to practice. So, I want you to take a look at this problem. We need to make a little bit of change here. That should be a times n. And this should be a divided by n. With that out of the way, pause your video and do your best to solve these problems. Okay, assuming you've paused your video, this first problem should be pretty straightforward. Actually, it doesn't need any of the information above. We're counting in a times b sort of way. The goal is b to the third. So how many times must we multiply b by itself to get b to the third? Well, that's 3. We're counting in a b sort of way. The goal is b to the third. That takes us 3 steps. For the next one, we need to know something about a. Otherwise, this problem is impossible. Fortunately, at the beginning, we're told that log base b of a is 30. That means we're counting in a b sort of way. The goal is a. It takes us 30 steps to get there. So we know a is b to the 30th. So wherever we see an a, we can rewrite it as b to the 30th, which is helpful because when our base matches up with the base here, we can say the answer is the exponents. Right now we don't have that luxury, but we can do a little bit of work to change that. So first, we're going to substitute b to the 30th in for a. Now b to the 30th to the 10th power, a power to a power multiplies the exponents, giving us log base b of b to the 300th. This is no different than the first problem, except the number is slightly changed. So the answer is 300. For the next problem, we need to know something about n. Similar to log base b of a, log base b of n tells us that b to the 15th power is n. So wherever we see an n, we can substitute b to the 15th power. So here, we're going to rewrite this as log base b of b to the 30th times b to the 15th, because n is b to the 15th and a is b to the 30th. Well, that equals log base b of b. Well, there are 30 b's being multiplied here, then 15 more, so that's a total of 45 b's being multiplied. Once again, once we're in this situation, the answer is very easy. 45. Now, if that helps, and you haven't gotten 4 answered correctly yet, pause the video, try to answer 4. Okay, assuming you've paused your video, it's the same technique. Instead of a times n, it's a divided by n. So log base b of b to the 30th over b to the 15th. That's log base b of b, and then this is where people get confused. They'll look at the 30 and the 15 and think, 30 divided by 15 is 2. But that's the wrong idea. You need to think about what b to the 30th is. B to the 30th means I've got a bunch of b's being multiplied, 30 of them, and I'm dividing 15 of them away. So that's b to the 30th minus 15, which is log base b of b to the 15th power, which is a lovely 15. So notice I used no special rules here, just substitution and the definition of the logarithm. As you go through your lesson, through the bookwork, you're going to learn that there are shortcuts, and you're going to see those shortcuts very similar to these problems 1, 2, 3, and 4. So what I want you to do right now is complete pages 934 to 937. Digital copies and solutions are available at goo.gl/chtos, whatever that is. So you can find the digital copy of the book, you can find the teacher copy of the book, and you can find extra practice problems there. Pause your video, complete those pages, and then resume your video, and we'll have a nice little chat. You still there? Oh, thank goodness. Man, if you didn't get to this point in the video, then how could I know that you learned anything? Man, you're zooming pretty quickly through that. You're a little trooper. Way to go, you. So what we need to do is add some things to our sheet here. This is in your I Heart Math Chapter 13 Learning Log. So there is rules of exponents and rules of logarithms. And as we went through this, you should have realized this really strong connection between the exponents and the logarithms. So the first we're going to do is take a look at the zero properties of powers, which is you take a number to the 0 power, it always equals 1. If you rewrite that as a logarithm, that's log base b of 1 is always 0. So no matter what the base is, if you're logging something, if you're logging 1, you'll get a 0. Now, if you have a base raised to the first power, that's b to the first, that equals b. Rewrite that in logarithmic form. Log base b of b is 1. These are the two critical points in logarithms. Things get a little bit trickier with product powers, product rule of powers. If you have b to the m plus b to the n, that is, times b to the n, that is b to the m plus n. Make sure you change that to multiplication. My apologies. So here, just like when you have powers being multiplied, you add the exponents. If you have log base b of m n, that's log base b of m plus log base b of n. Or you could say xy, xy, or alpha gamma, alpha gamma, for those of you Greek lovers out there. Now the quotient rule of powers, that's b to the m over b to the n, that equals b to the m minus n. So here, really similar rule, log base b of x divided by y is log base b of x minus log base b of y. There is nothing special about x and y, just that they're placeholders for whatever you want to put in there. It could be very complicated, or it could be very simple. What's critical is that the bases are all the same. Same thing for the product rule of logarithms. And on the side, you should come up with examples on your own. I'm not going to tell you which ones to choose. Last one is the power to a power rule. We did this in the opening. If you have b to the m, and you take that to the nth power, That means I have a bunch of b to the m's, and I have n of them. So if I have n groups of size m, that's b to the m times n. Likewise, and this is my favorite rule of logarithms, if you have log base b of x to the nth power, that equals n times log base b of x. I have a couple of warnings for you. These rules can only be used if you have exactly what you see here. For example, the product rule of logarithms cannot be used if there is a 2 on the outside. The power rule of logarithms cannot be used if what's on the inside of the argument, some of it is not raised to n. Here's an example. Here's something that doesn't work. If you have log base b of 5 times 2 to the 7th, you have to use product rule here because it's 5 times 2 to the 7th. You cannot use power rule because the 7 does not apply to the 5. So this does not equal 7 times log b of 5 times 2. That is bad math because here the n applies to the entire argument, but here the n does not apply to the entire argument. So pause your video and make sure you've gotten all this down. Alright, so I'm assuming you've resumed your video. Make sure you have 13.2 skills practice in front of you. We're going to take a look at a couple of problems here together. First problem is all the way down on 14. Pause your video and try to make a start there. Assuming you've paused your video, this is log base 5 of 7x squared over y cubed. The first thing we want to do is realize that there is a numerator and denominator, hence we'll use the quotient rule. So this is log 5 of 7x squared minus log 5 of y cubed. Now, here we can use product rule because it's 7 times x squared. So that's log 5 of 7 plus log 5 of x squared minus log 5 of y cubed. Now, here I can use power rule and here I can use power rule. So the first term stays the same, plus 2 log 5 of x minus 3 log 5 of y, taking the exponent down. And this is expanded form, ladies and gentlemen, because each log only has one item inside of its argument. And there's no way to extract anything else here. Now flip to the back side. I want to take a look at 22, so pause your video and try to solve it. Assuming you've paused your video, what we're going to do is work backwards to condense it. So I want to keep the parentheses together, and I'm going to do those first. So I can turn this 2 into an exponent. So that's log 3 of x squared. And same thing here for the 5 times. I can change that into log 3 of y to the 5th. And here, I've got log 3 of x to the 7th. Now I can perform the addition rule here. That's log 3 of x to the 7th minus log 3 of x squared y to the 5th. Now I can use quotient rule because I've got this minus that. So that's log 3 of x to the 7th over x squared y to the 5th. I can cancel out some of that. That's log 3 x to the 5th over y to the 5th.